Alright, so now what is dimensions? Now we should understand the fact that dimension is basically the use of fundamental quantities and not just quantities itself. We're working with their symbols, alright? Their symbols is what we're working with. The mass, length, the time, alright? Some people might add other concepts though, but we're mainly working with MLT, mass, length, and time to describe physical quantities. It's as easy as that, alright? So now we're going to dive right into the major aspect of dimensions, alright? Without any strings attached. I'll teach you how to calculate or get dimensions for some basic physical quantities. All right, now we're going to start with a common example where we have our speed. All right, we're going to deal with speed first of all. Okay, you can remind me of our formula for speed. I believe you should understand that speed by now is distance over time. Okay, and if you can record this effectively, we are good to go with this dimension. Now, since we know speed is distance over time, from our dimension earlier stated, okay, we have MLT. Distance stands for a length, okay, and that's going to be L. Time represents time itself, okay, and that's T. So if you take speed, this is raised to power minus 1, right? Based on this, you can see it as LT raised to power minus 1. Now I'm going to talk something really unique ASAP, okay? We're going to touch the velocity and compare the answer for speed and velocity based on dimensions. But before we dive right into velocity, let's check out the units for speed. The speed, L stands for the meters, then per second, that's all right, per time is per second here. So we have meter per second as a unit for speed from here. All right, so let's move straight to velocity. All right, so now this is our velocity, okay? We're going to compare velocity answer to speed and see what's going to happen. Velocity, as we discussed in our previous video, is displacement, all right, over time. Displacement over time. Now, displacement is the length, and we can say that is L all over time t. And L over t can be written as LT raised to power minus 1. And as seen in our previous answer, this can be written as meter per second squared as the unit. Now, these are dimension, answer, dimension, and here, and these are units. Now, you can see we've gotten the same unit, the same dimension, but guess what? There's a difference somewhere. Speed and velocity are not the same, all right? When I'm talking about speed doesn't have a particular direction at which it moves, all right? While velocity deals with a particular direction and which makes it a vector quantity. We'll be discussing that in another lesson. Alright, now we've gotten our dimension of speed and velocity, okay? We're moving straight up into acceleration and then we're going to touch the force, okay? Now for acceleration, we need to know fully well that this is acceleration, and then acceleration is gotten from velocity over time, right? For acceleration and velocity over time. Now, do you know what velocity is? Basically displacement over time, okay? Now, if we're going to use that here, I'm going to jump into that ASAP. Now, once you know velocity displacement over time, you can start solving and get your MLT aspect for dimensions there. But now, striving ourselves is stress. So we've gotten velocity already as LT minus 1. So we're inputting it here, okay? This is JAMB, WAEC, SSCE. You're going straight to the point and getting your answers correctly. For time, you have your T at the bottom. So using the law of indices, you're going to effectively get LT minus 2 here, and here you have your answer for dimension of acceleration. Now note, if you want to represent dimension, okay, let's say you want to represent dimension should be in brackets. Whatever you're representing as dimension should be in brackets. So you're going to have acceleration inside here. We're going to have acceleration, bracket of this, bracket acceleration, right? This square bracket is what is used to symbolize dimension. If you don't want to write dimension of acceleration is LT raised to power minus 2, you can easily do this in case of theory. All right, now for force, we're going to effectively get force as mass times acceleration. We've gotten acceleration already, and we're going to relate it. Good. Remember, we have acceleration as LT minus 2, and we have our force formula given. So remember, mass has M as its dimensional symbol, and acceleration we've steadily gotten that as LT minus 2. We're going to do the maths over here. M times LT minus 2 is going to give us simply MLT minus 2. Now you can effectively see the relationship between acceleration and force with this dimensional quantity given, all right? Now, this is one importance of dimension I need to note, okay? Dimension enables you know the quantities represented in a for the derived quantity, okay? You can carefully break down a derived quantity to fundamental quantity from just knowing dimension equivalent, right? So make sure you understand this, and see you in the next video. Sign out right about now.